All right.
I think we should be live. Double check.
Turn on my video.
That a cat t-shirt?
Yes. Yes,
Oh,
it is.
what kind of cat?
All right, we are live.
Oh,
We can discuss that later. All right.
Yeah.
Hello, everyone, and welcome to today's brand new episode of Courtcast. I am your host, Tim.
and I'm Mikey.
And this is Sahil. Welcome, everybody, to a brand new exciting episode of Quirkcast. Before we get started, if you haven't already, do join our Discord channel. And if you're watching on YouTube, where we do this every Tuesday, 5 p.m. Pacific, 8 p.m. Eastern, do ask us questions in the episode, and we'll get to it. So without further ado, let's get to it. So, Tim and Mikey, this is an interesting episode, a different variant from our past episodes on dark matters we've talked about, and a fascinating question of like, what would happen if this, matter that is permeates most of the universe, that we can't really see, didn't exist? What would happen to us? So I think before we delve into that, maybe Mikey, you look excited. I'm going to point to you first. Um, can you explain to the audience at a high level, like what dark matter is and why is it like important without, we don't have to delve too deeply into that question, but like, why is this even like an interesting question to ask?
Okay, so I think there's a lot of reasons why it's important, but I think I can just give one, and then we can talk about the rest later, right? I think
Mhm.
there's one that's basically kind of umbrellas the others. So dark matter. Oh yeah. So I guess we should back up. For those of you that don't know, uh, beings like humans, human beings, um, are beings of light. Um, Everything that we do, like the reason my hand doesn't go through my hand, the reason my hand doesn't go through this table, is because light particles are bouncing off of them and repelling. Um, the only reason that I know that anything is there, is because of these light particle interactions. So, um, if there is some substance in the universe that does not shine or reflect light or absorb light, if such a substance existed, then we would have no idea. Like it would literally, like it could be as dense as we are, and it would just pass right through us, right? I think a lot of people probably learned like in high school that most atoms are like whatever 99.99% empty space. So like
Mhm.
literally, if there's no light interactions, you just pass right through each other. And when we look out in the universe, we see a lot of signs that such a substance could exist. Um, in particular, when we look out at galaxies, what we see stars and galaxies moving around, but it seems like they're moving around under the influence of something invisible. Um, and it looks just like what you would imagine it would look like if there was a bunch of stuff floating around that doesn't interact with light. It would just be invisible completely, but you would see its effect pulling on stuff. Um, right? Like if the sun was invisible, you could know that it exists because you would still see planets orbiting around it, right? So that's kind of what we see with dark matter. We see this invisible stuff pulling and stretching on the stuff we can see gravitationally. So yeah.
Yeah, no, it's a great kind of high level foray into dark matter. I guess Tim, I want to ask you, like, we can't really see this stuff. Does it really matter? Like, why should I care? Like, this is the stuff I can't really even interact with. Like, I don't get to experience it on a day-to-day basis.
Yeah, I mean, as we all know, like just because we don't see something doesn't mean that it's not a big deal. So dark matter, as we'll discuss, play an enormously important role in the universe, and hence that's why this episode is interesting. Einstein is famous for thinking about the thought experiment. One curious thought experiment is basically to answer the question: how important, how much does our universe rely on this thing called dark matter? And I think the consequences are much. It goes much further than one might think. So dark matter is sort of this invisible hand, I don't know, of the universe that creates structures and stuff, and it influences a lot of, in many subtle ways, how the universe come to be. And in fact, our existence might partially be attributed to that in some ways, and this is why we're gonna get into.
Yeah, yeah, yeah.
I just wanted to mention
So,
one thing, like
mhm.
because we're going to get into a lot of the reasons why dark matter is important for our existence. But one of the things that is not often talked about, especially in the physics community, um, is the fact that so if you look at the numbers, right, a lot of people might have known that like there's a bunch of invisible stuff in this universe. There's actually 5 times more invisible stuff than there is visible stuff. And most of the time, as physicists, we have no idea what that invisible stuff is. So we naturally just assume, we start with the simplest assumption that it's just like a big blob of stuff, right? And we don't know what it is. But if you think about it, and I'm really glad actually recently, the venerable Catherine Zurich published an article about this on Quanta, really supporting the view that I've been kind of like supporting also over the last 5 years, against heavy disagreement from all of you. That like literally dark matter, it really, there could be dark chemistry, there could be dark atoms, there could be dark people, like there could be like really interesting things happening right next to us, literally, and we wouldn't even know it because they don't talk to light. So it's almost like having like separate dimensions overlapping on top of each other. Like it's almost like saying that there's parallel dimensions. Like it's in any kind of sci-fi interpretation of parallel dimensions, like this would qualify as that. So there's interesting possibilities there. But then, as we'll find out in this episode, it was also very crucial for our own existence, independent of the fact that it could be super interesting on its own.
Yeah, that's a great point that you mentioned. So let's start with at like the cosmological universe scale. Like, does dark matter matter? Like, would the universe be as interesting? Is my question. Either one of you want to point this
Yeah,
to.
so I want to clarify one point first. You got
Mhm.
our audience might see a lot of videos, be like, "Oh, dark matter doesn't exist. Einstein was wrong." Blah blah blah. Okay, so let us get out the window first. We're not talking about those hyperbolic, clickbait science article titles, right? Uh, so there are these like modified gravity theories or alternative theories about dark matter, but ultimately it's still dark matter. Okay, they need to account for this invisible influence of the universe. So our thought experiment is truly about what if this whole influence that we call dark matter does not exist. So it truly is a hypothetical scenario. So it's not like, oh, maybe dark matter really doesn't exist. No, no, no. We're not talking about that. We're talking about what if dark matter completely, that influence as we know it best, just wasn't there. So we're talking about different universe. And indeed, the universe will be so different. And I think the number one thing, the cosmological scale, that will change is that structures of the universe will be vastly different because we'll have way less gravity, basically. You're killing 80% of the gravity by matter in our universe. And that will make the universe very different.
So can you explain how that would make it different? Like, what would happen to galaxy? Like, let's start with galaxy formation.
Okay, I just want
What
to
would that
like,
look like?
yeah, this is before Tim get. Oh, nice cat.
Oh,
um, sorry, yeah, distracted by cats ever since I saw the movie Flow. But so um, I think it's fair to say that one of the main jobs that, oh yeah, well, first I want to say that, so just to back up what Tim was saying initially, what we're talking about we're not talking about like a specific model of dark matter, saying that that's not there. We're talking about every effect that we observe that is attributable to dark matter. So it's not totally model independent, right? Because the effects do depend on the model, right? You might have like one model that explains everything, like
mhm.
Like certain theories try to explain all of the observations we see. Some of them try to explain just one or the other. But generally, there's a number of observations that we generally attribute to some invisible external force that some people call dark matter, some people call modified gravity, some people call, I mean, in a sense, dark matter is modifying gravity in a way, right? It's like just by modifying it by assuming there's extra stuff there. And so, but the main thing that we observe dark matter doing is sort of like seeding, like, so when we look at the universe, there's a bunch of particles in the universe, right? But those particles tend to clump together into structures that we call like stars, planets, solar systems, galaxies, right? That requires, if you start with some diffuse material, according to even just Newton's gravitational laws, like eventually they're going to attract each other and clump into bunches. And that clumping is very, very important for us, right? Because if it didn't clump, then if like, you know, particles of dust and stuff never got together, then obviously we would never be here. And what we observe in the universe is that the dark matter is largely, heavily, significantly responsible for sort of seeding this clumping. So before any of the particles that we're made of could even start to clump together, first you need dark matter to clump together. And then all the visible stuff starts to clump into the dark matter. So if you look around every single like dense area, like a galaxy or a solar system, you see like some invisible influence here kind of acting as a seed, like holding it together and pulling in other stuff that's nearby and, you know, making things grow. So if there was no dark matter or something like that, I don't know, I would argue you wouldn't have any structure. You couldn't have galaxies, you couldn't have solar systems. I mean, it would be like 1 in a trillion, like it could happen by accident, right? But dark matter makes galaxies happen often.
Mhm. So if the universe were like significantly larger than, you know, this 1 in a trillion of like solar systems forming
Yeah.
would give rise to like a possibility of us like arising.
Yeah.
I don't know. Does that make sense?
Well, yeah, if the
Maybe you
universe
can
is
parse my
infinitely
question.
big, if the universe is infinitely big, then you know, something that's infinitely unlikely will happen. So yeah, it could be that we would find ourselves in a solar system that is kind of like a Boltzmann brain that just came together by statistical chance.
Well, I think the conclusion may not be so straightforward. Like without with less dark matter, like imagine you just throw away all the dark matter in the universe, then there's less matter, then there's absolutely will be less clumping. But it's also a little bit paradoxical because ordinary matter actually would like to clump very much. So the difference between dark matter and ordinary matter, one key property is that ordinary matter is what we call dissipative, basically. It's because it emits light, it loses energy. So when it clumps in a sense very violently. Like imagine you collide 2 planets together. When they collide, gets all smashed open, you know, energy is lost, and they really clump in a violent way. Dark matter, on the other hand, when they clump in a very kind of casual, gentle way. They form these fuzzy blobs, almost like
dark matter mostly goes through itself.
Right, basically, yeah. So it acts sort of like a scaffold for structures to grow. So without this scaffold, so that's some scenarios, right? Like what if instead of dark matter you replace it with some other ordinary matter, right? I would say there would still be some clumping happen, but then certain types of clumping might be a little too violent, and then they're going to make black holes, but then they will probably be a lot rarer. So I think there will still be some structures and maybe some galaxies occasionally, but
Some
you don't think so?
What about galaxies? Just galaxies?
Well, I don't know.
So like, well, okay. So what makes a galaxy different from just like a bunch of gas that collects? It's basically because the core becomes so dense, you get these stellar nurseries, right? And then you get star formation,
Right.
and that's a galaxy, right? But without
Yeah.
that, you wouldn't have any kind of stellar nurseries for sure, right? You might have a star here and
Uh,
there,
well,
and you might have an overdensity of stars that might get over threshold, but that wouldn't be like a galaxy.
I mean, okay, so this is up for debate a little bit, right? Like, so I think even amongst, even near Milky Way, I think we have some satellite galaxies that are close to it. That are not full-fledged galaxies, but are close to it that are very low in dark matter. You can do
Yeah, that's
measurements.
true.
So,
Yeah.
but then how much of the existence of those little dwarf satellite galaxy is due
Yeah.
to having the
Our
Milky
galaxy.
Way?
Yeah.
I don't know.
I don't think they would exist without the Milky
No,
Way.
I think chances are they could be. I think it's a matter of statistics, right? Like they were like
Certainly their density and size on average will be much smaller if they don't have like a parent source for gravitational wells, right?
I mean you could just have.
Having a C just increases the chances of collisions and interactions, right? Like it's almost like an accretion disk, right?
Yeah, well, I don't even know if structures like this can form. Look what, and also another thing that dark matter does is to stabilize the disk shape of galaxies.
Oh yeah, yeah.
Yeah, so it's almost like you know, like you put a DVD in your DVD drive. If the DVD drive doesn't exist, there's no place for it to spin around. It was just gonna fall apart. So the dark matter is kind of like the like the DVD drive to hold the disc in place so it can spin in a reasonable way. I mean, I don't know if that's a good analogy, but
Okay, I see where you're like. My analogy is going to be perhaps worse, but it would be like if you put a bunch of Cheerios on a record player that's going too fast, those Cheerios are going to fly away, right? But but if you have some if the Cheerios are kind of stuck attracted to the center by some magnetic force, then they wouldn't escape. And basically, if it wasn't for dark matter, galaxies would okay, let's say if all of a sudden, okay, let's say that dark matter is some substance it's responsible for gravity, and let's say all of a sudden, all at once, all of it disappeared suddenly. Every galaxy would just drift, fly apart. I think that's true, right? Okay.
that's probably true. Minus the enormous gravitational wave that will ensue, like the gravitational tsunami.
Oh, okay. No, it's gonna go down
Gradually,
perturbatively.
let's say. but But okay, but so I think it's up for debate. But I think there could still be structure. If you look at the enormous universe, which is infinite, I think chances are good that you will still find some. If I don't know if you call that galaxy, but clumps of
like binary system, right? Like two stars come close enough to each other, they're gonna get caught in a binary, right? A third one comes in, is gonna get caught in a tertiary, right? But I think on a whole, these clusters are gonna be a lot smaller, right? So maybe you'll have like a whole bunch of like very widely separated like small clusters of like stellar systems.
yeah, like maybe a few thousand stars. How about that? Instead of 100, instead of 10 billion in a galaxy, I think you can find a few thousand.
So now now every star system is basically some kind of like either binary system, you'd argue, or some kind of like loosely speaking, every cluster of stars would be like like 3 or 4 star system, right?
No, I'm not sure. I'm not sure if like this the densities of the universe comes from some quantum fluctuations, right? I think you can argue that at the very tail end of this quantum fluctuation, some of them might be very large, and then you just happen to get enough stuff.
But those quantum fluctuations, the current story is that those quantum fluctuations rippled out into the dark matter. So there's no dark matter.
Well,
wait.
Okay,
Yeah,
certainly certainly stars by themselves would be most common. You would agree with that, right?
Sure, I agree. Sure, stars would be way more common.
Exponentially less common would be binaries, and exponentially less common would be 3 star systems.
Sure.
Yeah, and so it would go like
possibly.
That. You would have some like 100 or 200, 1,000 stars, but it'd be extremely rare. Right.
Sure.
So my question still stands, like, how would that impact, say, solar system formation, for instance? Like, we only have one star. I mean, for my, for the solar system existing, it
Yeah.
doesn't seem apparent that it needs to be embedded within a
Well, there
galaxy
would
to
be a
actually
lot
kind of
less
form.
stars too. Yeah, because I
Mhm.
mentioned like a big part of why there are so many stars and why the universe is so bright is because galaxies often become what they call like factories for producing stars because these
Uh-huh.
gravitational wells created by the dark matter, presumably,
Mhm.
become so deep that the gas just collects and condenses, and you start getting hundreds of thousands of stars coming out of here. Like
Mhm.
if things were left on their own, then it would happen. But I imagine it would happen many orders of magnitudes less frequently. The universe would be a lot dimmer, that's for sure. And there'd be a lot of random
Mm.
dust floating around, so it'd be even dimmer. But not just because there's less stars, but because there'd be more ambient dust.
That's fair, but like, couldn't you say that if we exist in a solar system, even though it's very rare
Yeah,
in the universe, not surrounded by many things, then asteroids wouldn't necessarily be as much of a threat in
sure. But
some
you could argue
sense.
that asteroids were helpful for the formation of life. By
Ah,
But hold on. I think we're a little. It's a little too soon, right? Like we gotta look at what asteroids are made of. Like in order to have asteroids, you gotta have rocks.
you have to have secondary supernovas.
Yeah. So in order to have rocks, that means you have heavy elements like iron, nickel, I don't know, silicon, right? All that good stuff.
Oh
And,
gosh.
mhm.
and one of the problem with stars is like at the beginning of the universe, when the first stars were lit up, this is what we call the first generation star, and it's mostly just hydrogen because hydrogen is the most common thing.
The most boring stars.
It's super duper boring, and they're big and powerful, but they burn out quick. They just like
Uh,
hydrogen, burn the helium, and boom, they're done. Right. So in the early universe, there was actually a period where the universe was very bright. It's basically like a massive bonfire, and then at some point it
mm.
burned
Well, is it
out.
cool how the universe has like a preheating phase?
And then it burned out, and for a while it's like, wow, the universe went dark again. Um,
Uh,
and then it was actually until after when some of the heavier star goes supernova, so like really kaboom, and those shock waves kind of reignited the other stars in the galaxies, and then the new generations of stars that come in. And I think that's
mm.
the called the we ionization, but let's not get too technical. But it is because repeated supernova explosion within the same galaxy that keep depositing additional interesting material. Then the star, then out of the dust of the death stars, like a phoenix, they rise up again and form second generations and even third generation star. And then these stardust, the remnants of them eventually will come to form things like planets, like Earth and the Moon and
Mhm.
the other goodies.
Yeah, that's a really good
What?
point. I'm going back on this now. I really don't think it could be possible. So not only would stars be stars would be exponentially less rare uh just to exist, but yes, as Tim pointed out, it's our existence doesn't just depend on stars. But like right, you have these boring stars in the beginning of the universe, they're made of hydrogen. They blow up and they create light elements like lithium, carbon, and then that stuff recollapses into more interesting stars that blow up
Mm.
and create more interesting elements like iron, titanium, and then that stuff comes together and forms stars, and that stuff blows up and creates like uranium and like um,
Wait, can we like double click on this because I want to make sure I understand this. So my understanding of like current solar physics is that you have a star, it's made of hydrogen, has a certain amount of mass, certain amount of
mostly hydrogen,
material,
yeah, yeah.
and mostly hydrogen. And there's two competing forces. There's gravity trying to collapse everything in, and there's nuclear fusion happening in the core of the star. So
Yep.
then hydrogen fuses into helium.
Yep.
Then helium fuses in. I'm sorry, my knowledge of the periodic table is not
Yeah, me
great.
neither.
The next element, whatever force it
No, no,
fuses
no,
into,
no.
and then it just keeps
The fusion
fusing.
stops at the helium, right? The fusion doesn't. We don't fuse. It doesn't fuse helium into heavier elements than that. The interesting elements
Wait, I
happen.
thought there was fusion of helium into like something else.
Does there?
No, you need to be
It,
bigger. The
It
sun.
stops at iron.
No, no,
no. what you're talking about is like, yeah, well, what the iron is the line between when it's energetically favorable to split or to fuse.
Yeah,
That's true.
yeah, like I
Yeah.
yeah. So
Go ahead,
actually,
Tim.
the stellar physics is a little more complicated. So I don't claim to be an expert in it. But a star like the sun, it's not just hydrogen. It does have some other interesting bits. And astrophysicists call them the metallicity. You know, you can look at and the
Oh yeah.
sun is probably, I don't know, third generation, whatever. So it's not just hydrogen, right? You need to have the other extra stuff for the sun to be what it is. But the sun is probably going to burn out pretty soon, so it's not really going to efficiently burn a lot of the heavier elements. So it's not going to be able to create much of it. I think, like at the core, maybe it will do a little bit of funny stuff, but probably not enough to create it to the level that we see around us.
I just want to understand like what is in between these boring stars and the sun, for
Uh,
instance,
oh yeah,
because
okay.
yeah,
So yeah, it's interesting actually. So if you let's say we have a star that's completely boring, it's all made of hydrogen, right? Yeah. What
sure.
if you do models for supernovas? A supernova actually doesn't start at the center. It starts like in kind of like right around the core. So it
Wait,
explodes.
Mikey, real
Yeah.
real quick, can you define what supernova is? We've been throwing around this term. Is it when the star explodes, becomes huge? What is supernova?
Yeah, so a supernova is when a star is end of its lifetime and it's running out of fuel. And
Mhm.
so, like you mentioned, there's competing forces between gravity and the combustion of the fuel produces an outward pressure. So when the fuel
Yeah.
runs out, the gravity takes over. Um,
Hmm.
and then at a certain point, the density gets too high and things become unstable and it explodes outwards
Hmm.
in a bright explosion. But this explosion actually starts in a small shell around the core. So it doesn't just explode outwards, it explodes outwards and it explodes inwards, which means the stuff in
Oh.
the core gets super compressed and then it comes outwards.
Oh.
And then but that's how you get like uranium being randomly created in the universe. Like
Oh.
so super compressed during the explosion. And then it explodes all this interesting like gold, silver, all these interesting elements out, and then that's the stuff that
Uh.
becomes planets, like interesting planets that can make life. If it's a first generation,
Uh.
or most likely, it's not going to make any of the interesting stuff that we need.
Yeah, but I guess the
I
point is
see.
maybe we will still have enough, right? I mean, it certainly would be less interesting, but the question is, maybe there will still be, in very rare cases, like something like planets and asteroids,
Yeah,
remnants of stars that.
yeah, but they could never have civilization because they would never have energy sources they could harness, right? They would never be able to dig for coal, right? They would never be able to like
Well, I mean, coal is just carbon, right? Like,
reactors, right?
I, I think maybe it's plausible. Like
They
if
couldn't
we
mine for uranium in any kind of meaningful amount.
like for example, if you have some rare cases of like, let's say two neutron star happen to meet, they merge, and they will create something sort of like a supernova, like a kilonova explosion, and locally it will spew out a lot of like junk.
Yeah, yeah,
and then
really there.
right, and maybe for some freak accident, maybe there's some black holes nearby, and then the remnants eventually will form some solar system that is okay, interesting. And I feel like life could potentially form under these extreme circumstances. You think? No?
Yeah, no, it definitely could, but now we're talking about like exponentially rare possibilities, right?
Yeah,
Like
but
think of how nice the universe is for life and how rare it is. And
wait, hold on. We don't know how rare life is yet. I feel like there's a chance maybe let's say a universe is too conducive to life, and then maybe you create violent aliens that just try to murder everyone else. So like,
maybe, but like I feel like we should have seen some radio signals by now. Like it's weird. You'd think electromagnetic signals would be the first thing you play with, and you think that would be like kind of universal. And there's no one in our neighborhood, and it's a little
I
peculiar. Even
mean,
the city people find it a little bit peculiar. Like most like estimates for how often this could happen, even like very, very meager estimates would have you assume that we would be hearing some kind of like TV or radio signal from some being that learned how to manipulate
What?
electromagnetism.
Wait, Mikey, what if it's so compressed that it just seems like noise to us?
It could be, but people are really trying to separate the noise. There is a lot of noise and there's a lot of like, and people
Yeah.
once in a while you hear about these like quasars that get mistaken as like, oh, this is happening on like a 30-minute time scale, so it must be a civilization because it'd be coincidental otherwise.
Or maybe there's an enormous government conspiracy, you know? It could be covering the whole thing up. So
We should do an
I,
episode about that, but I'm actually
I like how we've gone from dark matter to aliens.
well, because it's
Natural for good.
relevant, right? It's kind of relevant because we're
yeah,
thinking about like
I guess okay. I guess it's fair to say that so without dark matter, let's say in the rare chances that life does exist, then aliens would probably be way rarer. I think that's
even
probably
more
fair.
rare than they are now.
I think that's fair. Yeah.
That
Definitely.
Yeah, I would probably agree with that. Um, and so I guess like, does we've talked about the cosmology scale, the galactic scale, solar system scale.
Oh yeah.
What about the planetary scale and even the subatomic scale? Like, does dark matter actually like matter? Even actually with planetary scale, we've discussed even like with nova.
Yeah.
But what about subatomic scale? Like structure of atoms and beyond that.
That forces us to get model dependent now, doesn't it? Doesn't it, Tim?
Yeah, I think you can argue that subatomic scale doesn't matter for the most part.
Yeah. Yeah.
Mm.
There's no subatomic phenomenon that where we say, okay, we need dark matter to explain this. People have made up many hypothetical subatomic phenomenon that they hope dark matter will explain, and then they've tested them and they've all come out as null results, unfortunately.
I see. I see.
Yeah.
I would assume that if you're doing a theory of like quantum gravity, then you would need dark matter. Is that correct?
Yeah, it's certainly if you're any theory of quantum
Yeah.
gravity would have to include dark matter in description.
Yeah, I mean, it's plausible that without dark matter, there would not be a consistent theory of gravity. It's plausible because that's the life we live in now.
Here, let's go back to the idea that I like. So here's one possibility I think is really intriguing for how dark matter would generically affect subatomic physics. So like I said, we are beings of light. Everything that we can interact with in the universe is also an object of light.
Mhm.
That is 5% of the universe. 25% of the objects in the universe are made of stuff that are not objects of light. So what could that be? One of the things, as you mentioned before, like one of the properties we know about dark matter is that it passes through itself. So this leads to the conclusion, this is why most people believe that probably doesn't have structure the way that our visible light-based universe has structure, because light-based structure can't pass through itself, right? Dark matter was like, some parallel universe with dark people and dark atoms and dark chemistry, then it wouldn't just pass through itself, right? But it could be that there's 100 different, it could be that there's light and there's dark light 1, dark light 2, dark light 3, and 100 different dark lights in the universe, and it could be 100 different, and then you would see most of them passing through each other, so that would explain it. And so I find this idea really compelling, that dark matter, it really could be a portal to a new dimension, for lack of a better description. I know it's not it actually might be dual description to a genuinely new dimension, but people talk about sci-fi and sci-fi stories where it's like, alternate realities right next to us. Like dark matter literally could be that. There's a whole bunch of stuff out there we observe that is completely disconnected from us. I don't know, what would you call that? I would call that an alternate reality.
Well, right now it's a very boring one, right? It's a very boring alternate reality.
Seems that way based on very little information. So I don't believe the universe would just make dark matter a bunch of boring, blobby stuff. Like that doesn't not seem characteristic of Mother Nature to do that. That seems more characteristic of a lack of human imagination.
Yeah, yeah. I guess what wait, so when you talk about dark light, it seems like an oxymoron.
Yeah.
Like you just like what do you mean by dark light?
Uh-huh. So we have our version of light that we call the photon. And
Hmm.
every single object in the universe that we can perceive can also perceive the photon. And we're
Wait, what
connected.
about neutrinos?
Oh yeah, except for neutrinos, but that's why those are not part of our reality.
Okay. Let's say neutrino does see light. It's just a
Yeah,
lot
but not
weaker.
really.
It's just a
Not
lot
really.
weaker than the way we do, and they see it in a little differently. They only see it magnetically, and it's very weak, but still it can be measured. Um, but or
So
at least
yeah. In my opinion, neutrinos live in this alternate dimension, alternate reality. They don't affect us. In fact, catching even one is so hard. It's ridiculous to build giant ice cubes.
Wait, I thought neutrinos have a bigger impact on our lives, like via the sun and stuff like that.
Solar
Doesn't the
neutrinos.
sun emit neutrinos or
They
something like
do.
that?
In the movie 2012, the whole premise was that solar neutrinos started interacting with matter and started cooking the Earth's core. But that seems silly. I don't think solar neutrinos
Oh,
affect us, do they, Tim? They can't.
I think it impacts the
Maybe it's
solar.
some really weird.
It might, well, it definitely impacts the sun in some weird way. Let me
It doesn't
think.
affect life though, right? It can't.
Probably not directly.
You know. As
Yeah, probably not.
far as we're concerned, they're ghosts. They're like literally ghosts, but like not like the kind that can't even scare you because they can't even make themselves known.
I think all
that's
occasionally they can they cause like memory corruption like they
No,
on
those are
rare.
usually other cosmic. I mean,
Those
they're
are those
different.
those are other
cosmic.
cosmic
Those are
rays.
usually muons or something.
That's true. That's true. Yeah.
Mhm.
Yeah, yeah. Um, Also, Tim, you were mentioning something about cosmic rays. Can you elucidate that further in the
Oh,
context of
there'd be
this
no
dark
cosmic
matter
rays if it
discussion?
was in the dark matter, that's for sure.
Well. The thing is, if you imagine this hypothetical scenario without dark matter, where structure is very rare, then
Mhm.
in order for solar system to form, then you probably have to place yourself in these really dense nuclear center of stuff going on, right? So
Mhm.
then you might end up with this like interstellar scenario. I don't want to spoil the movie for people, but like, in order for life to exist, we might be forced to live in this area where we're very close to, let's say, a black hole or neutron star, just because these have to be
Mhm.
so active in order for like something like a planet to even form. Unlike a
Mhm.
galaxy where it can be kind of more spread out,
Mhm.
because without dark matter, structure would tend to clump a lot more. So the question is, if you live in these places, is there enough time for intelligence to evolve?
No way.
Like there'll be so much more radiation. Like imagine we're close to a black hole or like a neutron star. We could just be blasted by like, I don't know, like gamma rays all the time. I don't know.
Hmm.
That could be bad for life.
Or it could be so good for life. Maybe life only exists close to black holes right now, and we're the exception. And maybe that's why we haven't seen any signals yet, because they're also redshifted, and because the time for them is basically standing still compared to us, and that's why we haven't seen.
Uh,
Or maybe life can take advantage of this abundant energy source. We can speed run it. Life will get speed run it. It's like overclock with all that gamma rays and jets, from the black holes coming at us. I don't know.
Ooh, it would be chaotic. There'd be a lot of chaotic events happening. Like when a paper was released the other day, just talking about magnetic reconnection, basically solar flares happening on black holes. So if you live near a black hole, apparently it would be a fireworks show. They said approximately like 3 to 10 times a day, you'd see a very bright spark. So if our sun was a black hole instead of a star, um, it would have a faint glow, but then like about about a dozen times a day, it would just spark. So, and each of those sparks, could blast deadly kind of radiation. But then again, radiation is, you could argue that that is the crucial element for mutation and evolution. So, yeah, maybe
Yeah,
maybe it's
maybe.
very rare for life to occur away from black holes. And maybe that's why we haven't seen any extraterrestrials.
Wait, when we say like near a black hole, how close are we talking? Like mad chilling on the event horizon, like very close to
Well,
that, or like how close is close?
They do this calculation in the movie Interstellar. How close do you have to be to get out of the time slippage? They do yeah. I can't do it in real time, but
I mean,
yeah.
this is all speculations, right? There's no detailed calculation. I don't know.
But
Close
it would
enough.
explain the what's it called? Like the Fermi paradox.
Mhm.
I think that's a clever, not before proposed solution to the Fermi paradox.
Things
Wait,
just live
so
close to the black holes.
Yeah, maybe life just favors forming close to black holes.
wait, but we're talking about hypothetical scenario, right? Clearly, that this does not this doesn't hold for our universe.
No, I mean it could hold for our universe. Yeah.
Ah, hmm.
Hmm.
Wait, but don't you need like I guess constant like is Hawking radiation enough from black holes? Like this like really
For
low
what?
energy sort
No, no.
Like,
radiation.
no, no, taxes are start. No, no, a black hole probably wouldn't. Like, yeah, probably couldn't have like it wouldn't expel enough constant, reliable energy to be a power source for a planet. So it would have to be some kind of like.
No, no. The powerful the power source is the accretion ring, right? Like the Hawking radiation is super low. I mean, it will take
Mm.
eons. So we're
What's
talking
the
about.
spectrum? I don't. What's the spectrum of an accretion ring? I don't know. Is
I
it
mean,
high
it's
enough to actually like
gamma
support?
rays. I mean, these are blaze. Well,
You wouldn't get blasted with gamma rays like if you were.
depending how big the black holes are. I mean, these are probably hopefully not super massive. These are probably solar sized black holes. I guess they're not going to be that deadly, but they're not going to be bright though.
Yeah, I
So
wonder if they could power a planet. Although I don't know, like if there's life on Jupiter's moons, that are literally just warmed from the flexing of the core under gravitational stress, and well, who knows?
I I wonder though, like if you could I don't know, just like if yeah, just getting enough energy source. So you're saying accretion disks wouldn't be enough.
No,
Well,
no, no, neither of us are qualified
yeah,
to
yeah.
estimate
Well,
Uh,
yeah. I
that.
mean, what might happen is I guess you could have a bunch of black holes and some stars and even like black hole star blind binary. Could be awkward system, and it's can life live in those systems? I think that's tough to say.
I I wonder if you keep getting blasted, like a part of, let's suppose a part of a planet keeps getting blasted by gamma rays and it's like kind of random. Do you
The
think
world becomes the
life
Hulk.
could evolve in some sense
Yes,
to like
everyone would be big and
repair?
green and
Yeah.
muscular.
Well, it's
Just
like the
like
three
immediately repair yourself. Like half of you is gone and just like,
it's like the three body problem. Is it what
It really
is
is,
that the
yeah. So
book?
yeah, but the truth is, we just don't know enough about like spontaneous formation of complex life. But
hmm,
I don't know, and probably most conservative people would say it's crazy, but I don't think it sounds crazy.
what that life is by a black hole or
Oh,
like what
well,
part's crazy?
that a black hole could produce some kind of energy spectrum and stability that would be like amenable to life. Yeah, like I think most people would say that's crazy, but
Hmm.
I don't think it's that crazy.
I think life could
Ah,
potentially adapt. I mean, there's some very radiation hardy
Life finds a way,
life,
man.
but this is like another level of hardiness, probably. Uh,
Yeah.
I mean, what if you just keep stealing angular momentum from the black hole and power your civilization that way?
I think you need advanced technology to even start to contemplate that. Like if you're a little amoeba on like some random planet near a black hole, you need to evolve first. So
That's fair. Also, another question is like, without dark matter, if planets do exist, would they be a lot bigger than Earth, like super Earths?
Ah, hmm.
Because then that'll impact like the gravity on the planet and the ability for the species to escape the planet and
That's
go
super
to
hard
other
to say.
places.
Probably because of the fact that things like dirt and rocks are so much rarer in this universe.
Mm.
The planets might be way smaller. I don't know. What do you
Really?
think, Mikey?
I would guess that everything would be the same, like to first approximation, everything would be the same except for the frequency of their occurrence, because protoplanetary disks, as far as I know, mostly come from the supernova, and nothing about dark matter, as far as I know, affects supernova dynamics. So even though it'll be a lot less rare, I think
Mm.
the distribution, average size, and stuff like that of planets, if they did happen to form, would be similar to what they are in our universe. They would just be
Mm.
exponentially more rare. That would be my
Mm.
guess.
Mm.
Oh, hey, sorry, I gotta take off a little early, but
No
Okay.
worries. No worries.
okay.
Yeah.
All right, later.
See
Uh,
ya.
I think I think Tim, is there anything else you want to mention in this episode? I think we're almost at the end.
Yeah. Well, I mean, there also is another consideration when I thought about
Mm.
this thought experiment. This is called gravitational instability. So the interesting
Mm.
bit is gravity is inherently unstable because things clump. Yeah.
Oh.
And so dark matter kind of the nature of dark matter, because it's less dissipative than ordinary matter. It gives it a little more stability to structure in the universe. So
What
if you get
what
rid
do you
of
mean
it,
by stability? Wait, like
Mhm.
gravity's like universally attractive. What's unstable about that?
Right? I mean, yeah. If you just naively think that something is universally attractive, then it's just gonna
Mm.
collapse into something singular, a black hole, basically. Right?
Oh, I see.
Yeah. And yeah. So and this instability goes in many names, and this is one of the reasons why a gravitating system actually has negative temperature. But let's not get into that discussion.
Mm.
But dark matter slows that down a little bit, basically. But without that, um, gravitating system might become quite unstable. And one thing that could happen is what we call gravitothermal collapse, which is literally that, because imagine you just grab a bunch of rocks, just keep throwing them at each other, because that's what gravity
Mm.
does. Eventually, they lose enough energy that they just get closer and closer to one another. And if it gets dense
Mm.
enough, and it would just form something super dense, and all that interesting structure is gone. And if there's enough
Mm.
mass, it would just collapse into a black hole, right?
Mm. Mm.
So the question is, if imagine we have a solar system, or like stuff that's around, or maybe a little larger, like a star nursery in this low dark matter environment. Is it
Mm.
plausible that because of the lack of dark matter, there could be more gravitothermal collapse and cause these structures to just self-annihilate?
Wait, what do you mean self? It sounds like an explosion or something like that.
Well, yeah. What I mean is just it clumps too much, and just these little structures
Mm.
would just clump together and just get destroyed because
Wait,
you know.
if dark matter is like clumping or like soft clumping, why doesn't this exacerbate the problem like today?
Right, because dark matter, once they clump to a certain extent, they don't clump anymore.
Mm.
Kind of. It's kind of like a cotton candy, right? Like it's got these fluffiness because
Yeah.
dark matter moves very fast. You know, in order for you to clump things more, you kind of have to press it down, hold it down. You got to slow down the dark matter. But remember, dark
Mm.
matter is dark. You can't touch it. It doesn't emit light. You can't push it.
Mm.
So when you try to let's imagine this, the dark matter particle, you try to press it in gravity, then it just fly to the other side. So it's almost like this little
Mm.
balloon. You squeeze one side, it goes out the other, right?
Mhm.
So it's this sort of bounciness nature of dark matter that makes it not so clumpy. Yeah. But
Wait, how do you know? How do you know it's moving fast? What's like a simple way to think about that?
well, actually, if dark matter didn't move fast, galaxies would collapse. Basically, I mean that's the explanation.
Oh, because it would just be all kind of in one place, and that would
Yeah.
just be
It will
self.
be
Mhm.
exactly. It will be way clumpier. So dark matter's got to be diffuse. It's got to be like cotton candy. If it's not like cotton candy, like we wouldn't even have galaxies. So that's sort of the explanation. And there will be a lot more black
Mm,
holes for sure if
mm,
all the matter just clumped up, right? But
mhm,
now we're removing all that. We're saying that hey, look, but we still want stars and life. But in order to form stars and life without dark matter, they got to be way closer to one another. But then they got to be
mhm.
way clumpier, and the gravitational instability is going to be even more. Um, so there's a
Oh,
yeah, so there's concern that everything could just destroy themselves.
and and by destroy themselves, you mean just become like black holes, essentially?
Possibly if there's enough mass. Of course, if there isn't enough
I
mass,
see.
it just become a mess, right? Like imagine if you merge the Earth, Mars, Venus, Jupiter, all mash them up together, and it would be nothing. Just be an asteroid mess, right? Asteroid field. So
Yeah, yeah. That makes sense. Just this like giant messy ball or something like that, right?
right, and then you can argue that maybe life would just not have enough time to form. But who
Mhm.
knows? You know.
Yeah, yeah. That is interesting. Okay, so there's gravitational instability that comes about because there isn't this like cotton candy like thing that's kind of holding things together in some sense.
Right, yeah, and I think from calculations, dark matter is roughly moving probably 1,000th the speed of light, and this is a lot.
Whoa.
Okay, so
Yeah.
it's like is it like many hundreds of kilometers per second or something like that? Something like that. It's fast. Dark matter is moving real fast.
Wait, wait, then how does it form a cotton candy shape if it's like if it's just moving really fast? Like it sounds kind of like how I think of like neutrinos where they just like move in this straight line and they just keep going. Like there's no care. They just pass through everything. Like what can you give me some better visualization of this?
Yeah, so they are definitely almost definitely passing right through us at super speed, but
Hmm.
they do move around on in the galactic scale. That's what it is. You know, they might move from one end of the galaxy, just whizzing around all most of the stars, but then because there's so much of it, and the large scale
Hmm.
gravity across galaxies will eventually curve them around, so they form like a little ball, like a cotton candy ball. So they do orbit.
Wait, so is it orbiting like really fast around the galaxy or
Yeah.
what does it look like in terms of like how it's moving? Like if I were to kind of draw it like a fluid.
I mean, the thing is, like on average, it's not moving because as much dark matter rotates one way, you have other dark matter moves the other way, so they cancel out, right? So
Are you, oh, go ahead. Sorry. Finish.
yeah, so I mean, it's kind of like the gas, in this room, right? It's they
Mhm.
move at super fast speed, like I don't know, 500 meter per second, something like that. The gas molecules move super quick. We don't feel
Yeah.
very much of it. Yeah.
Mhm. Yeah, but there are walls in my room to like they bounce back and stuff like that. There's no wall as far as I know in the
Right, but
galaxy.
yeah, but these are
Yeah.
enormous. Like the gravity of a galaxy is enormous. It's enormous size. Like it's just millions of light years. So it bends the dark matter ever so slightly, but after it travels of
Mhm.
millions of light years, so for sure it has enough time to kind of turn around.
So I'm just trying. Okay, so I just really want to like visualize this because it's difficult for me to wrap my arms around. So imagine you have this like pancake like spiral of the Milky Way, and then are you saying like dark matter kind of goes like this, and then like at some point it's like, does it make a sharp turn and then comes around? Like, is it kind
No,
of like this, or is it like more circular? Like, I don't know. Like, how should I think about like how it flows? I
yeah,
just really
yeah,
want
yeah.
to wrap my arms around that.
I think it's like it's a very gradual, slow turn. Um,
Okay.
of course, we don't know the true nature of dark matter. It could be like
Yeah.
a gas; they could collide one another. But
Mhm.
it could be like a glass. They could collide with one another as long as they don't lose too much energy.
Mhm.
But if they don't, yeah, they would just kind of circle around the galaxy. But remember,
Mhm.
because it doesn't have any preference. It can circle around every which way. It doesn't know about the disk very much because it doesn't talk very much to the ordinary matter.
Mhm.
So you basically have a crap ton of like particles circling around the galaxy. So it's like a big blob, basically.
Mhm. Mhm. My one thing I have is like, I wanted to slightly touch upon a more speculative thing, or maybe not as speculative for you, which is black holes. So when black holes form, it's like you have a sufficient amount of mass, it collapses into a small enough space, and a black hole forms. Clearly, there's probably dark matter that's involved in this process. So I'm wondering, like, you know, has there been any speculation around like, dark matter's role in black hole formation that you know of?
So there are possibilities where dark matters could stop black holes. Actually, it could cause
Oh.
a black hole to collapse, but that's speculative. Um,
Mhm.
but these are very specific models. Um, so for the most part, maybe indirectly, because at least most of the small scale black holes that we see, like solar mass black holes, that we see, come from stars, and dark matter is important for star formation. In a
Mhm.
galaxy, right? Um, so um, so indirectly it has it so indirectly it has an effect, right? Um, but there are also other black holes, like supermassive black holes at the center of galaxies.
Mhm.
Those we actually don't quite know how they're formed. My
Mhm.
personally, I'd probably bet decent money that uh, dark matter is responsible for the formation of those
Mhm.
supermassive black holes. So if you remove um, dark matter, then yeah, maybe those enormously sized, like millions of solar mass black holes, those might be gone,
Mhm.
and we wouldn't have these fancy pictures of from the Horizon Telescope of
Yeah.
images of black holes, because those are really large black
Mm.
holes.
I'm also curious, like, is it, I guess, how likely is it that there's a black hole that's purely made of dark matter? Like, so much dark matter just collapses in on itself and forms a dark black hole.
I mean, it's plausible. I mean, once a black hole is formed, you don't really know where it came from. So a black hole is a
Yeah.
black hole, right? Yeah, it's plausible that black holes, like dark matter, could create black holes. In fact, I've written papers on it.
Huh.
Yeah, if dark matter has some really funny reactions, it could collapse
Mhm.
a lot more than ordinary matter, and some of them could make into it could create more black holes than you would think, and a lot of those
Mhm.
black holes might be quite dark, right?
Yeah.
Uh, like you can't see black holes really,
Yeah.
unless a lot of stuff is falling into it and it emits like X-rays and all that. But then the black hole has to be around other stuff to cause this disturbance. But if there's no other stuff around, like there are probably sci-fi movies where a black hole could just like fly toward the Earth and we might not notice it until like, I guess Interstellar is one of them, right? Like until it gets so
Uh,
close and then it screws up everything. So yeah, it's not uh, black holes. Yeah, it's plausible that dark matter could cause some black holes to form, but then how much does it affect the structure of the universe? I don't know.
so Okay, sorry. Last question on this for my own speculative musings. If you had a sufficiently powerful enough computer, could you figure out like where a black hole came from? Such as and would that allow you to figure out if it was made of dark matter, for instance?
Could you?
Like sci-fi level powerful computer, just highly unrealistic based on what's available today. If definitely not within my lifetime.
The answer is probably not. I mean, you're referring to the Hawking radiation. Does that contain
Yeah,
information of what fell in?
yeah.
Plausibly, I mean, it might tell you something. But no, but I mean, Hawking radiation takes a long time to come out. Like
Oh,
eons. I
definitely.
mean,
You
no
got
creatures.
patience.
Yeah, no creatures will exist at that point then. But if you have an all-powerful being,
Yeah.
then
Yeah, yeah,
then maybe,
yeah.
sure, you know.
Fair enough. Fair enough. So we're almost at time, and so I wanted to give you a chance to leave with the audience with any words of wisdom that that the hypothetical absence of dark matter has taught you.
Yeah, I think that the exercise tells you that document is actually way more important than you think.
Mhm.
Um, and like sure, it doesn't directly affect us right now, but in the beginning of the universe, like it pretty much is critical for the right structure to form. And without dark matter, man, like I mean, yeah, probably galaxies, planets will be like we mentioned will be way different. But there is also a sense how much of our discussion is very much anthropic, right? Like
Mhm.
we and sometimes it is helpful to widen our imagination. Like I mean, of course, we don't know. We only have one universe. Like maybe without dark matter, life could still exist. Maybe it's not as important as we
Mhm.
think. But at the end, we are where we are. Like our universe has an abundance of dark matter, and it
Mhm.
has a lot of. And dark matter helps us make structure, helps us make stars, helps us make galaxy. So for better or for worse,
Mhm.
we have dark matter. And maybe it's a curse, but mostly, I think scientists tell us that it's kind of a blessing. So
Mhm. 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 And I mean, it seems maybe it follows the theme as we've talked about and other things that like it's a blessing in the past, but maybe it might be our part of our own undoing later in the
yeah,
future.
probably. I
Yeah,
mean that much we don't know. Yeah, but there's always this anthropic bias. We exist
yeah,
now,
yeah,
so how
yeah.
can it not be a blessing? So
That's fair. That's fair. I'm just being overly pessimistic. Anyway, so yeah. So on that note, I want to thank Rory for joining us, and we'll see you all next week.
all right, thank you all. Bye bye.
Yep. Bye.